Welcome to this course on industrial computers and applications. In the modern world, computers are not limited to offices or research labs, they are at the very heart of industrial production. Industrial computers provide the backbone for automation, process control, data analysis, and decision-making. They enable precision, speed, and efficiency in manufacturing systems. This course is divided into two modules. Module 1 will focus on types of industrial computers and their operations, as well as numerical methods for computing. Module 2 will emphasize the applications of computers in production and manufacturing, including their role in production planning and control. By the end of this course, you will understand both the technical aspects of industrial computers and their practical applications in real-world manufacturing environments. Module 1: Types and Operations of Industrial Computers. 1.1 Introduction to Industrial Computers. Industrial computers are specialized computing devices designed to withstand harsh working environments and to perform critical tasks in production systems. Unlike conventional personal computers, industrial computers must operate reliably in conditions that may include dust, heat, vibration, humidity, and electrical noise. Key requirements include rugged construction, long life cycle and reliability, compatibility with industrial protocols, flexibility for integration into manufacturing systems. 1.2 Types of industrial computers. Industrial computers vary in form and function. Some major categories include programmable logic controllers, PLCs. These are dedicated devices used for automation of industrial processes. They are extremely reliable, with simple programming languages tailored for sequential logic and control tasks. PLCs run machines such as conveyor systems, robotic arms, and assembly lines. Industrial PCs. These are rugged versions of personal computers, designed to perform more complex tasks like data acquisition, visualization, and advanced control. They often serve as supervisory computers in manufacturing environments. Embedded computers. Small, specialized computers built directly into machines or equipment. They perform dedicated tasks such as sensor monitoring, motor control, or communication with other devices. Supervisory control and data acquisition systems, SCADA. These combine computing and communication to monitor and control large-scale processes, such as power plants, pipelines, and manufacturing plants. Distributed control systems, DCS. These are networks of computers used in continuous process industries like chemical plants and oil refineries. They allow for distributed decision-making while maintaining centralized monitoring. 1.3 Understanding the operations of industrial computers. The operation of industrial computers depends on three fundamental roles. Data acquisition, collecting data from sensors, machines, and production systems. Examples include temperature sensors, pressure gauges, and motion detectors. Processing and control, applying logic, algorithms, or models to interpret data and make decisions. This may involve regulating motor speeds, controlling robotic arms, or adjusting process variables. Communication and visualization, transmitting information to operators and other systems, often through control panels, human-machine interfaces, or remote monitoring software. Industrial computers must operate in real time, meaning they respond immediately to input without delay, ensuring smooth and safe production. 1.4 Numerical methods for computing in industry. Industrial computers frequently use numerical methods to solve engineering and production problems that cannot be expressed in simple equations. These methods include root-finding methods, used for determining process parameters such as control setpoints. Interpolation and approximation, applied in quality control and predictive maintenance when estimating missing data points. Numerical integration and differentiation, useful in analyzing signals, vibrations, or thermal variations. Optimization techniques, applied in production planning, scheduling, and resource allocation to minimize cost and maximize output. Simulation methods, used for testing manufacturing processes in a virtual environment before implementation. These methods enable industrial computers to process large amounts of data and provide solutions that guide real-world decision-making. 1.5 Case examples of industrial computer operations. In automobile manufacturing, PLCs control robotic arms for welding, painting, and assembly. In food processing plants, embedded controllers maintain the correct temperature and mixing ratios. In power generation systems, SCADA systems collect data from turbines, transformers, and substations, ensuring continuous monitoring and quick fault detection. Module 1 Summary. In this first module, we explored the world of industrial computers. We studied their types, PLCs, industrial PCs, embedded systems, SCADA, and DCS, and examined their operations in terms of data acquisition, processing, and communication. We also highlighted the use of numerical methods for solving industrial problems. This foundation sets the stage for the applications we will study in the next module.